Okay, so it's a differentiable function g satisfies this over here. And this is the part where I read this and, what do? You have to understand there's a method to get to the answer. But over here, so it's true for x greater than or equal to 0. And this is find g of x. All right, so they give me something, they want me to find something. So I wrote it down, and then what I did, looking at it, I decided I was going to split it. Right, I'll tell you what I mean by that. If you look at this over here, if you split this thing over here, you get 0 to x. And just, one way to split it, just, get the x gt. I'm using the distributive property of multiplication to do this, by the way. And I'm also splitting the integral into two parts, by the way. You get plus another integration, 0 to x. And the thing that's left over is this thing over here, which I'm going to rewrite as 1 minus t times gt dt. So that's all I did in that second step. And then what I did, I said, well, maybe I could just differentiate, because the right-hand side is really easy to differentiate. And the left-hand side looks a little tricky to me. All right, but I'm going to differentiate both sides now. And again, the right side, really simple to differentiate. You get 4x cubed plus 2x. Left side's a little more difficult. And what I noticed about this over here is that the first integral, the x can be pulled outside the integration. So I would actually recommend that. And the reason for that, I start to realize this is a product rule. All right? And I'm using the fundamental theorem of calculus to do this, to differentiate it. And it's a product rule, but before I do that, I want to point out this guy is fairly easy to differentiate. All you're doing is evaluating the function that's on the integrand at x. So that guy integrates really simple, and it integrates to this thing over here. So I'm going to say this one's done. But the other is a little more complicated, all right? So it's going to be the derivative of x, which is 1, times the integration, which is 0 to x, gt, dt, plus the first function, x, times the derivative of that integration, which is just going to be g of x, I mean. All right, now where's this written down? I see this, it's right here, and then I see this over here. Then I look at this thing and say, where's this going? And I look at it, and there's something really nice about it. And what is nice about it is that some things disappear. Like this guy here would disappear with this guy here. And what am I left off with? Just g of x, right? Relatively simple. But I'm still at that integration, by the way. All right, you get a little bit easier each time I put it down, by the way. And what do I do now? I differentiate again. All right, I keep differentiating, and I want to point out differentiating these sides is fairly easy to do. And I'll go one step at a time, and I get 12x squared plus 2. Derivative this thing is going to be, I'm sorry, I got it backwards. I just recognize that. The derivative of the first thing is g prime, and the derivative of this thing is just going to be g of x, all right? Now this is the part where I'm going to say most people are going to get stuck. However, there is a technique, you may not know it, and people refer to it as undetermined coefficient, and then followed by integration by parts, all right? So what they're looking at this over here, and they're introducing an integrating factor to it, and it's e to the x. And the reason for that, once they write this down over here, and they're multiplying both sides by e to the x, by the way, they notice that this thing is just a product rule, all right? What do I mean by that over there? That gx e to the x plus g prime x e to the x is simply just the derivative of gx times e to the x. That's all it is. That's what's written over there. And what I do over here, I just distribute this across those two terms, and that's what I get there. Then I start to realize that, I can easily start to integrate now, right? So they're not worrying so much about constants until I get all the integration steps removed. But this guy integrated would just be this over here, and this guy a little more complicated, right? So I kind of write it down, but I kind of split into parts, by the way. So I took this thing over here, and, I pulled the 12 out, and you get, x squared e to the x dx. This I just pulled the 2 out, and I get this over here. I will say this, though, that, let me get my eraser out now. Get a bigger eraser out now. All right. My claim about this one over here, easy as far as integration goes. Easy as far as integration goes. All right, just that's over there. And then, this, not so easy. So I just want to briefly go through it for you. And not that some people do it quickly. I can't do anything quickly. But I'll write this down over here. E to the x dx. I'm going to use u is x squared. And that means du is 2x dx. E to the x dx equals dv. And then e to the x equals v. Integration by parts, by the way. Put this over here. That's going to be x squared e to the x minus 2x e to the x dx. Got to do integration by parts again, by the way. So u equals x, du is equal to dx, and then I'm left with ex dx equals dv, e to the x equals v. I think I can do this now. Again, it takes work. You get x squared e to the x minus 2. Let's see what you get there. You get x e to the x. Let's see. Then you're going to get minus e to the x dx. All right, I can finally pull it off now. You get x squared e to the x minus 2x e to the x. Let's see, plus 2 e to the x. All right, let me show you where that's written down. And remember, we had a 12 in front, by the way. But I want to make sure this is written down for you. And what's that going to be? X squared e to the x minus 2x e to the x plus 2 e to the x. And that's right over there. All right, I keep kind of plowing through this thing over here. And what next thing I do is I divide both sides by e to the x. All right? And if you do that, it's relatively simple because each one of these terms has e to the x in it, including that one over there, by the way. You can get 12x squared minus 24x. And then, I think I made a mistake somewhere. Oh, no, I didn't. There's a 2 over there. So it's going to be 24 plus 2, which is 26. And then I see this c and divide through by e to the x, get e to the minus x. And then the next thing I did was I just simply said, oh, g of 0, because I wanted to see if I could figure out what the c is. But I don't know what g of 0 is, right? But I could write that down, g of 0, because I said it's going to be true for all x greater than or equal to 0. I'll just write it down. So I know g of 0 equals, 26 plus c. So what I did, I went back to the original problem, and you know what I did? I just kind of plugged it in. And I plugged in x is 0, by the way. So let's go through that. And I want to point out where that's written for you. Let me see if I got that written down for you. Yeah, it's written. Got to make sure I'm doing over here. This one over here. All right, I'm using this over here. The original problem, by the way. So write down the g of 0. 0 to 0. X is 0, by the way. gt. If this is 0, that's just 0, right? And what do you get over here? Well, that integration over there is just 0. And then you get g0 equals 0. What does g0 equal, though? 26 plus c. So I'm seeing that over here. Do I know what c is now? C is minus 26. So I go back up here, and I just plug that in. And what'd you get? You get this over here. All right? So that's g of x is equal to this thing over here. Is that what they wanted to know? That's what they wanted to know. And this is written over here. Find g, we found g. Did it take time and effort? Yes. Could someone get stuck here? Of course they get stuck. What do I mean stuck over here? Right? They may not know about that, or they may not be able to remember that. It's possible over here. This is a good place to get. If you got there, you did a pretty good job. Thank you.